Hi, my name's Kyle Lyon. I'm a system architect here at Solutions PT, and this is part two of our guide for how to set up the performance module in AVEVA Insight. In part one, we discussed what the Insight performance module is, and we set up the mandatory sections by defining our equipment, the states those equipment can be in, our availability, performance, and quality metric targets that define our OEE, our good and waste production classifications, and finally, some of our utilization reasons, both the generic ones that we can use across multiple pieces of equipment, and those very specific ones to individual assets. Now, we did all of this using the pre-made sample CSV files that are available right here within Insight to build out our bottling line example. And we're going to continue to use those CSVs in this episode as we define the additional properties relating to our production runs. We look at how we could go about connecting to live data values coming from our SCADA system or PLCs. And then finally, we'll wrap up by organizing our equipment into production lines and having a little look at what we've built as a finished product. Now we've set up all the required components. Now we've set up all the required components, we can start looking at some of the optional sections, starting with the OEE Data Properties section because we've already filled in our utilization reasons section. The OEE Data Properties provide operating context for our utilization and production events. For example, these might be what crew is currently working, the product ID of the particular product that we are producing, what shift is currently working, or what work order ID are we currently working towards. During operation of a piece of equipment, an operator can set these OEE data properties to values that reflect the current operating conditions, or we can have them come automatically from things such as our PLCs, our SCADA system, or even if we get information from an ERP system. These values can then be used within Insight to group report. These values can then be used within AVEVA Insight to group report data when we're analyzing our actual OEE. So let's get these values. So let's import the values from the base spreadsheet. And we can see here that the sample ones include a crew name. So we've got a pick list for an operator to choose from, which is blue crew, red crew, and yellow crew. We have a slot for the product ID code and a slot for the work order ID that we're currently working to. Next up is the Automated Data Collection tab. This allows us to map tags that already exist within Insight's data structure to the details that we've set up here, so that our OEE tags can receive values directly from the actual instrumentation rather than us needing to upload CSV data or manually interacting them through the equipment efficiency pages as we'll do later on in this video. Now, for the purposes of this demonstration, I'm not going to import these since I don't have a data source configured to provide them. And the idea of this video is that you can follow along, run the lines that we create manually, just using those without any extra requirements needed. And then maybe look to tag those up in a demo app if you'd like in the future. But we will go through each of these just to show what would be expected in them. Now, before we start looking at them, just a general note. General best practice here is to use tags with a data change trigger as opposed to a periodic trigger. This means that we'll only prompt an update of these values when that value actually changes, which will optimize system throughput and query times by minimizing the logging of unnecessary data. So to start with our utilization reason tags, these are used to subscribe to and process utilization data using value, timestamp, and quality indicators, or VTQ for short, from a piece of equipment. So let's get these imported. Now those are important. We can now see that those columns that we have here are our namespace, the piece of equipment which it's referring to, a tag reference that we want to bind our values to. So this is the tag coming from the live data source that's going to be feeding us the values that we need to determine what utilization reason we're currently in. Additionally, we also have the default utilization reason that'll be there if we haven't received any data from a live data source up until the point that we do then receive that. And you can see in the final column here, we have the tag validation column. This is just letting me know that the tag reference I've defined here doesn't exist within my current AVEVA Insight tag dictionary. That's fine, that's expected on our end, but obviously if you guys are connecting these two live data values, you can use this to determine whether you've got the right tag name or maybe there's been a mistake in the CSV import. Now, the tags that we define here should be providing specific values. These tie back to some of the things that we set up in the previous video. So just to show you, if we go back to our utilization reasons section here, and we go to our equipment automation values here, we can see that we already defined values that we should be getting from a live data source that map to the utilization reasons we set up. So for example there, our Austin Kappa 1 dot utilization reason tag that we define then should be providing numerical values like 111, 112, and 113, and those will be automatically mapped to the correct string from our setup here. So in the instance of 111, it is for the Kappa is running. Back in the automated data collection section, we next have the production counter tags. Production counter tags are used to subscribe to production data, again using that VTQ standard. And let's get those imported and see what we're looking at. Now that's imported, we can see that again we have our columns of namespace, the particular piece of equipment that we are looking at, the tag reference, so again this should exist within the AVEVA Insight tag dictionary for you, the disposition reason that it maps to, and again the tag validation column. Now you can see here, for example, we have the suffixes of GP, WP, and RP for tying to good production, waste production, and rework production, respectively. But obviously, you can use whatever naming scheme fits the model your business uses. These are going to be counters that are defining our good, waste, and rework production. So they should be continuously updating. And then we can use the actual disposition reasons later on to define what type of maybe waste production that is. Next up is our OEE Data Property tags. Again, let's get those imported from the sample file and have a look at what the result is. And we can see here that we're mapping these to the properties that we just set up earlier in this video. So the crew working on the run, the current product ID that's running, the work order ID that we're working towards, and we've got those for each individual piece of equipment across our production lines. And finally, we have our production run tags. So these are used to, again, subscribe to that production data coming from our live data source. So let's get the sample file imported and see what we're looking at. So here we can see that again we have the namespace and equipment that we're looking at. But we've got some different columns now. So we've got a column for trigger production run. So this is a tag that we want to use to indicate when a production run is starting. And then we can automatically provide some data about this production run. Again, this information would usually come from the likes of your ERP, but can also be manually inputted from SCADA systems, which we can then obviously publish from there from the likes of InTouch or System Platform. So the planned quantity we aim to produce during this production run, the planned duration of the production run, the ideal rate that we want to be running towards, the ideal rate unit of measure. So what what metric are we running in? In this case, we might be bottles per minute. And then the ideal rate time, so the ideal production rate that we want to be at in regards to the time metric. And then the ideal rate time as well at the end there.